So we're working with NASA Johnson Space Center on jointly developing an exoskeleton for a variety of purposes. Their interest in exoskeleton work is for exercise in microgravity environments, and our interest is for rehabilitation and mobility assistance. Our EXO project, the design of the X1 is kind of only part of what our exoskeleton work is. We've got about 3 or 4 other sub-projects on the exoskeleton project that all feed into mobility assistance and sensory substitution. So one part is we're working with Anil Raj on the sensory substitution, restoring proprioception to people who are paralyzed and using these mobility assist devices.
We've been working with the robotics group to integrate sensory augmentation to the exoskeleton for individuals with paraplegia or spinal cord injuries. The big problem with just giving an exoskeleton to somebody who is paralyzed is that they also are no longer able to feel their lower extremities. And so the goal is to allow them to perceive the position of their legs, the forces in the motors, and the ground reaction forces using tactile displays on the torso, on the abdomen, and on the tongue.
And in that, we're measuring the ground reaction force through sensors that are at the feet and trying to use that information presented to the user and have them assist in balance. Part of that is redesigning the ankle and the foot plate. So there's some mechanical design that we're performing in tandem with Anil's group working on the sensory substitution part.
We're using a modified TechScan pressure sensor array, and that allows us to perceive or to receive 960 different points on each foot, and with that information we can generate very accurate center of pressure on the foot estimates, as well as know where on the foot the body is loading its weight, whether that's on the toes or on the balls of the feet or on the heels. And with that information we can control toe off and perception of slippage of the foot against the ground.
We think the ankle is a pretty important part for paraplegic mobility in terms of how you design the springs and where you provide the support.